software engineer in one of the FANG companies, and today we will be looking into one of the most asked question, that is valid anagrams. And as you can see, there are a lot of companies that ask this question, so it's a good question to get a hold on. So before going into this question, I'll suggest one thing. From my past experiences, I have given a lot of interviews in the past few years. So from my past experience, what would I suggest you guys is just go through this question, try to solve it on your own, and once you have given enough amount of time, let's suppose 15-20 minutes, then only come to this video. Do not watch this video without trying, otherwise it won't help that much. So this is from my personal experience. Don't just sit and watch videos, just try to solve the question on your own first and then see how it goes. Okay, so now let's start with this question, that is valid anagram. And as you can see that there are a lot of companies which have asked this question. So let's first understand what is an anagram. An anagram, as the definition is already given to us, is that after rearranging the word, let's suppose in the sorted order, we can see that all the words that are used in string S are exactly used in string T. It's just they are just misplaced, or they are not in the same order. So our aim is that if it is a valid anagram, that all the characters inside the S is present inside the T as well, then return true, else will return false. Fine. So as we know that we should approach a question in such a way that we come up with a brute force approach initially, and slowly and steadily we go to the most optimized solution. So when we talk about this question, what is the first intuition that comes to your mind? I guess you already know about this. While explaining this question itself, I have given you guys an hint. That is, how about we sort these two arrays and then just compare if they are equal or not. If they are equal, then we'll return true, else we'll return false. So this will be a brute force approach. Okay, let me write it quickly. Where we will sort both arrays and see if the values are matching. If they are, then we'll return true, else we'll return false. So let's talk about the time complexity. As we know that we will be sorting the string itself, and let's assume that both of the strings have a length of n. So in the worst case, sorting it up will take n log n. So this will be a time complexity, and it's not a good time complexity. And one more on top of this, we will be sorting this first and then we will be sorting the other string. So it's not n log n, it's actually n log n plus n log n, that is 2 n log n, which is not a very optimized solution, I would say. So can we think of a better solution? Just give me a minute. Okay, can we think of a better solution? How about we use some sort of data structure to see how many occurrences of A we have encountered, and then use one more hash map to see how many occurrences of all the characters in T we have encountered, and then compare if both occurrences are same or not. So that is one other way, that just track down how many times A came in, how many times N came in, how many times G came in, and so on. So one approach that is coming to my mind is a hash map. How about I save all the occurrences of A at one place, N at one place, and see if all the occurrences of hash map 1 is equal to hash map 2. But that still does not sound very optimized, because we will be using two hash maps, and comparing itself is a very tricky part. We have to check whether that value is there inside the other hash map, and then we have to compare all together. How about we use a single hash map? How about we keep on adding inside our hash map? That is, let's suppose we use a hash map. Okay, and what we are saying is, let's see if I can write it in a proper way. Okay, what I'm saying is, how about I save how many times A have occurred? So till now a have occurred once, so I'll assign 1 to it. Then we have encountered n, so we'll add n, and we will say that it occurred once. Then we encountered a again, and then we will increase our a value to 2. Then we encountered a g, so let me quickly write 1. Then we encountered an r, let me write 1. Then we again encountered an a, we will increase the count, and then we encountered an n. So this is the first hash map that we have. How about instead of creating a second hash map, I use the same hash map and keep on decreasing the value within the assigned keys of the hash map according to the values that we are just getting inside our second string. That is, we will see, do we have n? Yes, we have n, so we will say let's reduce it to minus, like just do -1 with its original value, so we'll get 0. Fine. Then I encountered a, I'll say let's decrease its value by 1, so it will be 2. Then I encountered a g, and I'll say let's decrease its value to 1 down, like whatever the value is, let's decrease and let's do -1, so it will be 0. Then I again encountered an a, so I'll again reduce the value, so it will be 1 now. Then I encountered a r, I'll reduce the value. I again encountered a, I'll again reduce the value. I again encountered an m, so I'll reduce the value to 0. Now I'll just check that if any of the value is anything other than 0, that means these two are not the anagrams. Even if they are negative values, that means few values were extra in the other string. If any of the values is positive, that means some of the values were extra in this string. So at the end of the day, we will check that all of them should be 0. If at any point we encountered a non-zero value, we'll return saying that that is not an anagram, we have found a non-zero value. Fine. So that will be our approach. So let's talk about the time, space and time complexity. So as you can see, we will be using a hash map. So the space complexity itself will be O of n, depending upon the length of n, and we will have a time complexity of O of n. Basically, we will be traversing through this, and then we will be traversing through the next array. So it will be n and n, and I think we will be traversing once again to scan the entire hash map, checking if any of the value is not equals to 0. So overall we can say that the time complexity is n. Now when it comes to the space complexity, let's think again. In the worst case, all the 26 characters will be there, but there will be no space which is more than 26 characters. We will be looping within those 26 characters. So it's not O of n, it's actually stationary, that is O of 26. So if we see in that way, then our space complexity is actually constant, so we do not have to worry about it, and we can see that we have significantly improved our time complexity to O of n. Earlier it was O of 2n log n. So we have done a good job. Okay, let's talk about a third scenario or third optimal solution, which is very similar to the second one. The only difference is that instead of using a hash map, how about I just use an array of size 26. The same thing will happen, your space will still remain the same, your time complexity will still remain O of n. What we will be doing, we will be scanning over all the characters, and what we will do that each index will represent the values from A to Z. So index 0 means A, index 1 means B, and all the way index 25 will be Z. So what I'll do, I'll just say that give me the character that is there with you right now, let's suppose CH, and subtract A from it. So this will give us array of some values, either it will be 0, 1, 2, 3, and accordingly at that particular index we will store the count. So we will keep on incrementing the values, whatever the number of time the values are occurring, we will keep on adding it for the string s, and for the string t we will keep on decreasing it, and at the end of the day we will just loop over the entire array to see if any of the value is not equal to 0. If it is not, we will just return false, else we will return true. So instead of hash map, as I mentioned, we can use an integer array as well. So these are the three approaches. The second and third are almost the same. Instead of hash map, we are using a very traditional array, which is kind of better, I would say, because here although we are using a space of 26, but still we are using two space internally, one to store the key and the other one is to store the value. So instead array is a good option. Overall it will definitely help us in space complexity. So let's code it up. Okay, so as we mentioned, let's declare an array. Okay, that will be of size 26. Fine, let's see what's the next step. Our next step is to traverse the string s and keep on adding the count to those particular indexes within our array. So let's traverse to all the characters that are there inside our s string. Okay, so this is the way we get each character at a time from a string. While looping we can we can convert it into an array and we can just get one value at a time. So this is the way to iterate over n string. You can use it everywhere, so just keep this in mind. Now let's see what we need to do. As I mentioned that we will be taking the ch, whatever the character we just got, and we will be subtracting a out of it. So this will give me the exact index. So if you see, if it is a that I got from my character, so it will be a minus a, that will be actually 0. So these are subtracting the actual ASCII values. You can't see it right now. I guess the ASCII value of small a is 97, so it's basically 97 minus 97, so that will give you 0. So this is how we will be storing the count at 0th index. So we will increment it. Whatever value we have, initially it is 0, so we are incrementing it with 1. So this is how we will be storing all the counts of the string s. Now we will do the same with string t, but instead of adding 1 to it, we will be subtracting 1 to it. So let's copy the same code, and instead of s we will be going with t, and instead of adding we will be subtracting. That's it. Now our goal is to just check that while traversing my array, if I see any value which is not equals to 0, that's a red flag, and we will just return false out of false out of it, else we will return true. So what we want to achieve out of it is, when we are traversing over an array, if any of the value is not equals to 0, that means either it's the particular value is positive. If it is positive, that means there was some extra values at s. If it is negative, that means there was some extra values at t. But if we see that none of the values were anything other than 0, that means they are the exact match. Whatever value we have gained at s, we were able to neglect it by traversing at t. So we will do the same thing. So let's quickly traverse over the array, I would say. So let's do this. I is less than 26, I plus plus, and what I'm doing, I'm just checking that if array of I is not equals to 0. If this is the case, okay, that means we have encountered some different value which is not there in one of these strings. So we'll just return false. Okay, but if we are able to come out of this for loop, that means this if condition was never true, and that means all of the values are actually 0, which in turn means that we were able to find the exact match of the values that are there inside the second string. So we'll return. So this is the approach. Let me quickly check if this is working. Okay, this is working fine. We can now submit it. Perfect. If we see that the space complexity is very good, because at the end of the day we are looping n plus 26, which is, in short, we can say is O of n, because 26 anyways is a constant time space. If we talk about memory as well, it is O of 26, which is still a constant value, so the memory is constant as well. So that's it. It's a very easy question. I'm starting off with easy question. This is my second tutorial that I'm presenting, but eventually I'll start pumping up to a more harder problems. Let me know if there is any feedback. That's it for today. Thank you.